Welcome to Beyondshodh, a podcast where we delve into the minds of remarkable scientists, innovators, and visionaries in STEM who are shaping our world. I'm your host, Dr. Soumya Balyan, and today we have the privilege of sitting down with a true luminary in the field of biotechnology and academia. Our guest today is none
Dr. Channa S. Prakash, a distinguished scientist and professor of plant genetics, biotechnology, and genomics at Tuskegee University in Alabama, USA. He is also serving as the Dean of College of Arts and Science, Tuskegee University, USA. With a tenure on the faculty since 1989, Dr. Prakash's contributions have significantly impacted global agriculture and scientific discourse. His research expertise lies in genetic improvement research focused on food crops crucial for developing countries. His lab was at the forefront of developing transgenic sweet potato and peanut plants, pioneering groundbreaking genomic studies on peanuts. For nearly 3 decades, Dr. Prakash has been a leading advocate of crop and food biotechnology awareness worldwide. His efforts extend beyond academia, engaging policymakers, farmers, and the public alike. His work has been instrumental in promoting technologies that address global food security. In 2015, Dr. Prakash received the prestigious Borlaug CAST Communication Award, recognizing his unparalleled contribution to advancing agricultural technology capable of feeding the world's growing population. As the editor-in-chief of the esteemed journal GM Crops and Foods, Dr. Prakash shapes the discussion and disseminates knowledge in biotechnology field. Nature Biotechnology has named him as one of the top personalities who have made the most significant contribution to biotech, while his peers recognize him as one of the 100 top living contributors to biotechnology. Additionally, he holds the Little of Biotech Food Hero by CropLife International and was a finalist for the New Foodfluencers Award by the US Soybean Export. Recently, Dr. Channa S. Prakash has been elected to the 2023 class of Fellows for the American Association for the Advancement of Science. His impact extends to social media, where he engages with the global audience. With 96,000 followers, he generates an average of 10 million impressions per month on Twitter and Facebook, making him a leading influencer on agricultural biotechnology issues.
The list of his contribution and achievement is extensive and deserving the entire episode to summarize. So, without further ado, let's welcome Professor Channa S. Prakash to Beyondshodh. We are very delighted to welcome you, sir. Thank you so much for providing us the opportunity to feature your journey and research to our audience. Welcome to Beyondshodh.
Thank you, Dr. Sonia Balyan. It's my pleasure to talk to you.
So, to start with this conversation, sir, can you please provide us a brief overview of your research and professional journey for our listeners?
Yeah, thank you so much. I'm an agricultural scientist, and I grew up in Bangalore, in southern state of Karnataka, and I did my bachelor's, BSc in agriculture, and MSc in genetics and plant breeding. And then I did my PhD in Australian National University, working on forest genetics. And then later, after completing my PhD in Australia, I did my postdoctoral research at University of Kentucky in Lexington, where I learned many of the techniques of plant molecular biology. It was essentially just starting at the time, as you can imagine, in the mid 80s. This was just a field that was being born. Transgenic crops had just been transgenic plants for the first time has just been reported a couple of years before, and there is considerable excitement for plant breeding students that this is a new tool that is developed, that we would be able to use this to improve crops in a much more precise and in an expedient manner. And so, although my earlier training, I did not have an opportunity to learn biotechnology because it simply didn't exist at the time. Later, I was very fortunate to work with scientists and able to learn and go to some of the training programs. And so when I got a job at Tuskegee University as a young faculty member, I started my lab and beginning my work on sweet potato and groundnuts, simply because those two crops were the focus of research at that university. There was a very eminent scientist called George Washington Carver who had worked on those two crops, and so I began working on that. And essentially, it was a clean slate at the time. There was really not much research publications on biotechnology of any crops, especially crops of importance to developing countries. So I chose to work on sweet potato, which is the sixth largest food crop in the world. And groundnut, of course, is a very large source of protein, and cooking oil, as you know, include popular in India as well. And so my lab initially was able to do some interesting work on developing tissue culture methods for those, and able to develop protocols for introduction of foreign genes into these croplands, and we were among the very first to report transgenic crops. And the term genetically modified was not prevalent at the time, and it was kind of came about later. And even today in science, as you know, we use the term transgenic crops or bioengineered crops as a way to designate those plants that have been transformed with a foreign gene. And then I also began to work on the genomics of those two crops. And I'm very pleased that one of our very first collaboration on groundnut was to train ICRISAT scientists. ICRISAT did not have a genomics program at the time, so we got a lot of groundnut varieties, but also many related species of groundnut. Groundnut originally comes from South America, and so we had an ICRISAT scientist as a visiting scientist in my lab, Dr. A.K. Singh. So we were one of the very first to report identification of genetic variation in groundnut, and then help start a genomics lab in ICRISAT. This was in mid-90s, and as you know, ICRISAT now is a global leader in genomics of crops, especially legumes, under the leadership of Dr. Rajiv Varshney, whom you had in your podcast just recently. And then I'm also very proud that a student that I mentored, Robert Mwanga, who through a scholarship I helped bring him to the United States. And although he did not do his PhD with me because we did not have a PhD program in my university at the time, and Robert Mwanga, I'm sorry, went on to introduce orange-fleshed sweet potatoes in Africa, and it's grown along more than 15 million hectares today, literally transforming the vitamin A status of many of the African people who were, there is a major prevalence of vitamin A deficiency across Africa, and for that work, Robert Mwanga received the World Food Prize. And one other young student who was also at North Carolina State University working on sweet potato that I mentored is Dr. Mehta, who is now the global South Asia head of Gates Foundation. And so one other scientist that I mentored, who replaced Rajiv Varshney, a young Kenyan lab technician that we trained in genomics. So my pride looking back at almost 40 years of research is not only in that we were working at a very small university. Tuskegee is not a very large university. It's like a small college compared to India, only about 3,000 students. was that we helped start work in a field in plant biotechnology that blossomed later, but also train a lot of scientists from India and Africa. And but in the past 20 years, more than research, my work has been in really in trying to help bring an awareness on biotechnology and help trying to address some of the public policy issues related to regulation and acceptance of this technology, including India. For instance, when India was beginning to introduce BT cotton, as you know, BT cotton is genetically engineered to resist an important pest of cotton, for which literally lots of pesticide has been sprayed in India. And I worked along with a lot of Indian scientists. At that time, I was on the External Overseas Advisory Committee of the Government of India's Biotechnology, Department of Biotechnology, the DBT. And so I had an opportunity to be in India many times. And I, along with many other scientists, help bring an understanding of what is this technology, talking to a lot of farmers organizations, a lot of scientists, and also the media. And today, as you know, India, 95% of Indian farmers grow BT cotton, and India is the largest cotton producer in the world. And India, which used to be a cotton importing country, has now become a cotton exporting country. And so that has been, in a nutshell, what I can say has been my life in research and in outreach.
And at that time when all these technologies was just starting, and
Right.
mostly people are selecting rice and the crops where the resources were available. But at that
Mm.
time you were selecting the sweet potato and these peanuts. Uh,
Right.
there must be no these databases or genomic resources available
No.
for that crops. Then you
Right.
from standardizing the protocols to making transgenics and
Mm-hmm.
very great lots of work and very commendable work, sir. So
Thank
why
you.
exactly you have started with peanut and sweet potato and not with very easy crops? What exactly is the vision of selecting these crops, sir?
Right. You see, most of the cereals were not easy to transform. And of course, there's a lot of, bigger universities with greater resource working on those. So I thought working at a smaller university which had a history of serving underrepresented minority populations here in the United States, and also a history of working in the developing world, working on crops like sweet potato, and also later we did some work on cassava or tapioca also. And these crops were really ignored by biotechnology at that time. And many of the international agriculture research institutes today, which are leading in working on those crops, including ICRISAT and the International Potato Center and ICARDA and so forth, really did not have any biotechnology research going on in the late 80s and early 90s. And so focusing on a crop, first, we didn't have much competition working on this crop with other scientists. And secondly, it gave us, I think it was an opportunity to unravel science in a crop, in crops that have been largely marginalized and yet played a very important role. Because today, as you can see, India, I think, has Green Revolution helped with wheat and later with rice. But at the same time, it also helped bring too much focus on those crops to the extent that many of our traditional crops were being ignored. And today, I think there is a revitalization, a re-understand, or a refocus on crops like millets, for instance, like bajra and jowar. And in South, we eat ragi, the finger millet. And those crops are very resilient and considering agriculture is going to be facing a great difficulty with the global climate change. We already see today the global climate change and the tremendous rains that you saw in Dubai and Nairobi, and then the repeated heat waves and increasing drought. Agriculture is going to be the largest affected segment of our society in any country. And we in plant breeding have a great responsibility in ensuring that the crops that we grow, the crops that feed us, are resilient to this climate change, and these millets, which already are very adapted and very resilient, provide a great opportunity for food security. But they are not as productive. The farmers don't grow ragi or bajra as much as they like to grow wheat or rice, is because of several reasons, including price support and the policies, and also the productivity. So we have a chance now using biotechnology, especially the new technology of gene editing, to very quickly to develop these crops to be more productive, bit tastier, and they're already very nutritious, many of them, and very resilient. But we can increase its acceptance through technology.
It's very true, sir, because we are all over exploiting only few selected crops and then neglecting
Right.
most of the crops. And now we are paying that price because mostly depending on rice and wheat, now we are having diabetic issue and other things, health issues also
Right.
emerging. And we know that scientific community knows that genetic engineering has the power to support the farmers to make the to speeden up basically the process of designing varieties for future ready climate. But recently also, sir, I'm listening to your one interview when it came very early on in BD Metro, the channel. So that debate is with Dr. Shiva, I guess.
Vandana Shiva.
Yes, Vandana Shiva. And that is very early on, almost 20-25 years back.
It's 21 years ago, yeah.
Yes, but still, I think there is lots of resistance and lots of, in India also, we have BT cotton and then we have so much of policies and then talks are going on and on and on for years. But still we don't have a solution, sir. It's just now that government have allowed some genetic engineering methods to generate varieties and all. Similarly, the case with brassica, when earlier I am discussing this issue with Professor Pentel, he's saying again that it's very tough to convince the policymaker, and then after a few times when the government changes, the policymakers changes, all that issue. But certainly with all those things, but we are not still a strong point. What exactly are the myths that we need to clear as a scientific community so that people understand, especially the policymakers understand that this is the need of an hour? Why is there a lot of hesitancy, and what exactly are the myths or misinformation that we need to convince the policymakers and also at the broader level so that the general public can also understand the need of the genetic improved crops? What exactly are the worries of the policymakers that it will be misused or something like that?
Yeah, thank you very much. I think you really laid it out very clearly that we have problems and we have some possible solutions, and why are we so hesitant in moving forward? And it comes from primarily comes from a misinformation campaigns leveled against genetic engineering for the last 25 years, including Dr. Vandana Shiva that you mentioned, with whom I had debate many years ago, many times, including the one on Doordarshan. The problem in today is, once Carl Sagan, the great science communicator, said that the science moves faster at a faster pace than our society can keep up with it. And so at that time, I think genetic engineering came very, suddenly it was burst out on the scene, and most people had no idea what this is. And so there was understandable apprehensions in the beginning that this is a new technology, and so we really do not know the consequences of that. And so there was certain understandable emotional reaction to any new technology, as you can imagine. But what is sad about that is that certain sections of the society, the activist groups, exploited that understandable emotional reaction into a motive for them to move forward into a campaign against this technology to the detriment of the society. And because we have almost 40 years of knowledge with these technologies, and even in India alone, BT cotton, if you listen to many of the concerns that were expressed earlier, that this cotton is going to destroy the lives of our farmers, it's going to make India bankrupt, there's going to be unforeseen ecological catastrophe. None of that happened. In fact, India had a very large reduction in the use of pesticides, at least in the first 15 years of this BT cotton production. And farmers did not go bankrupt. In fact, lakhs and lakhs of farmers, cotton farmers, and most of them with 1, 2, 3 acres of crops are profitable, becoming increasingly prosperous. And so if we extend this technology to a lot of other crops, including rice and wheat, and you mentioned okra, do you know that in India, BT, in brinjal and cabbage and cauliflower, our farmers spray about 50, 60, 70 times. They are literally drenched in pesticides. And here we have a technology that reduce the pesticide production by almost to zero. And yet we are not able to move forward with this technology, not because there is anything wrong with this technology, because India is one of the best scientists in biotechnology. You yourself are trained in biotechnology, so you have a very good understanding of it. We have a very good, robust regulatory system, and so we have the infrastructure and the scientific capability to ensure that any products that we bring from biotechnology are tested for food safety, tested for its environmental consequences, and we know that we have a good regulatory system, and yet that has been hamstrung by very nefarious means, including using the legal. They have literally weaponized the Indian legal system to bring halt to some of these technologies, including the mustard that you talked about that was developed by Dr. Pentel. And so the problem is this: the politicians, the policymakers are not very keen to move forward in a very bold and courageous manner, simply because they are afraid of the attacks by activists who have also bought into the media, which is, instead of reporting it in a very unbiased manner, or instead of talking to scientists like you and many of the scientists that you have talked to, like Dr. Pentel or Dr. Varshney, they talk to a lot of opinion makers who are not necessarily trained in science. And thus it leads to they simply create a doubt about this technology, and so the tendency of politicians is to simply do nothing and just ignore this technology, and that is what has happened in India and a few other countries. But on the other hand, just look at all the stakes that we have. India, with 20% of the global population, have 6% of the arable land. And so we do not have the luxury of ignoring solutions that help India's food security. You see, today India is the 5th largest economy in the world, and it would not have been so if we had not improved our agriculture. You see, in the 1960s, when I was a child, India was deep problem with food. As you know, when Lal Bahadur Shastri, the Prime Minister at the time, asked all Indians to fast for a day, simply to save food. I remember as a child, standing in the ration depots for hours just to get some rice and dal. And today, India exports $30 billion worth of agricultural products. As you know, when we suspended rice exports, the whole global rice market was in upheaval. So India is an agricultural superpower today, primarily because of the tremendous investment we made in agriculture, starting with Dr. Swaminathan's leadership in bringing green revolution to India, starting with all the agricultural universities and putting together a very good extension system to help bring an understanding of the new innovations to our farmers, but also help improve the private sector so that many of the agricultural commodities, the seeds, and all of that could be brought to farmers in an open manner. And so we must continue to do that. Just like we embraced plant breeding and we embraced many of the systems to help improve, including irrigation and automation, all of that helped improve agriculture. To move forward in feeding 1.5 billion people with the limited land that we have and with all the constraints of the climate, and to bring more nutritious food and in a sustainable manner by being gentle on earth, with not degrading our natural resources, soil, water, and air, because we already see the cost of agriculture. To do so, we must embrace many innovative solutions, and biotechnology is one of them, but also the many other options. I'm really excited about what artificial intelligence can do to agriculture. Even big companies like Google and Microsoft have big divisions of agriculture and help bring more knowledge, even with limited acreage of the farmer that she has, that it is the knowledge that is going to drive future of our farming, and AI and many other technologies, the GIS, and the use of sensors, and all of these innovations would help empower our agricultural sector in India, that even with fewer people being involved in agriculture, India would still be able to produce enough food to feed not only her 1.5 billion people, but also can also be a huge exporting powerhouse.
Sir, very appropriately explained. But in your view, what exactly are the most breakthroughs in biotechnology that has the power to address the climate change issues and soil degradation, food security at the global scale, and how together as a global community we can bring about these changes?
Yeah, thank you very much. Agriculture moves incrementally in a history, not a huge, except in green revolution with the dwarf genes. But if you can imagine, we were able to feed 1 billion more people with just discovery of a dwarf gene in wheat and a dwarf gene in rice. And they are just, two genes. Imagine what power biotechnology can have, because you literally have the power to harness every gene. Now we have the knowledge. The cost of sequencing has come down so much. We can literally sequence thousands of varieties of crop plants, and then we have the power to understand what do they mean with the computational biology, with the bioinformatics, with the power of artificial intelligence to make sense of the data. And so what I think would be, and then the gene editing, the CRISPR technology that has come about in the last 10 years, where we can tweak individual genes in a very, very precise manner, and so many new tools being developed almost on a daily basis because of its application in biomedical area. What I believe, if we have a more facilitating environment to bring these technologies and to commercialize its technologies, I believe that we will be able to improve crop plants to begin with, so that they are more resilient to drought and more resistant to increased temperature and flooding and salinity. Those are many of the elements of the climate change. And also we would be able to improve the food quality of many of our crop plants, because you see, the food that we eat today is more or less kind of accidents of history. Not all of them are necessarily very, by alone, each crop is not necessarily very nutritious. Whether you look at rice or wheat or any of the maize or corn, any of the major crops that we eat, have certain deficiencies, and some have even toxicity. You see, you eat kesar dal in northern parts of India simply because it's very hardy and it can grow in very drought conditions, but it has neurotoxin, as you know. And then we also have tapioca that I mentioned has cyanide. So many of the legumes that we eat, like I was just in Egypt, and they eat fava beans, which is very popular there, and it is, there is a certain level of amount of toxicity in that. And so there are certain deficiencies in many of our millets in nutritionally. So with biotechnology, especially with gene editing and the knowledge of genomics and proteomics, metabolomics, and the phenomics that you mentioned, all of them used in a very integrated manner can help tailor our varieties in our food crops that we grow and make them more resilient, make them more nutritious, and also more productive. We have seen instances where just by flipping a couple of transcriptional factor type genes, where we can improve the productivity sometimes 20-30%. And rice, for instance, is a seed, in terms of its photosynthesis, as you know, is not as efficient as maize or sugarcane because of the C4 photosynthesis type that it has. And if we can integrate some of the 30-40 enzymatic pathways that are in sugarcane or maize and bring it into rice, we can literally triple the production of rice. Just imagine. And there's also, there are a lot of scenarios. There is a company in Israel and in United partnership, the branch in US, have an audacious goal of growing rice in the oceans. Rice that can grow on a salty water, that it could be grown on the ocean. So just think,
you have shared on Twitter, sir. I have read that.
you have said that, you see, and so those are some of the breakthroughs, transformational things, although it may or may not happen, but just think of it. We spend so much money, the farmers spend so much money on fertilizers, and a lot of fertilizers, and the indiscriminate use of fertilizers has brought so much damage to our environment, especially to soil. And so we can take, conceptually we can if we can make our cereals like rice, wheat, and maize and sorghum and all of that fixed nitrogen, just like what our dals would do, then we don't have to put nitrogenous fertilizers in that. And so those are some of the long range targets of biotechnology. C3, C4 pathway in rice, or making our cereals fix nitrogen. But in the short term, I would think we are going to gain from use of biotechnology in a meaningful manner with short-term increases in productivity, but greatly improvement in nutritional, just like the golden rice, for instance, and definitely crops that have a great resiliency for climate change.
For example, we have other options like mostly people support organic farming. We have seen that organic farming alone cannot be sufficient for dealing with future challenges that we will be getting due to climate change and other. Then again, the major point of impressive, or you can say guessing, is for the policymakers. Given the urgency of climate change and food security, what role do you believe that policymakers and regulatory bodies should play in fostering innovation and responsible deployment of biotechnological solutions in agriculture? Because I think in biomedical sector, the amount of acceptancy is far more as compared to the agriculture sector. So there is a little biased there when it comes to agriculture and adopting the innovations at the ground level of for science. It is there. So, what advice you should give to the policymakers to make this process little
Right. I think policymaker should not be swayed by some fashionable terms or some trendy terms that may, be be very kind of sexy from a very public point of view, but they need to think more in terms of science-based and evidence-based solutions for long-term solutions to the problems. Organic farming is more of a marketing term that is used in India and elsewhere, primarily because it is many of the solutions that it seeks for the problems are not necessarily grounded in science. They are more ideological than scientific. But the objectives of our organic farming is very noble. In a way, there's nothing wrong in increasing the use of chemicals in your farming or the use of synthetic chemicals in your diet or being more environmentally friendly. Those are good aspirations. But the path taken to achieve those aspirations are not really grounded in science, and many of them are, you know, there is not much truth in saying that they don't use pesticides, because organic farmers, they do use pesticides, and some of those pesticides used in organic farming, they are biological based, may even be more harmful than the synthetic counterparts that we use. And there's also a lot of fraud that goes on in organic farming. As you know, when you go and pay twice as much for an organic rice in your local store there, you really don't know how much of organic practices they followed. And finally, one of the biggest problem with organic farming, as we see, as scientists we see today, is they're less productive. If organic products cost twice as much because they are half as productive, right? And so we need more land to produce the same amount of food to feed the existing population if everybody ate organic, if all farmers followed organic farming. And that is going to destroy whatever little forests we have left in India. All of them have to be brought under cultivation. And so this is not a viable solution as a policy for a large country such as India with so much problems. What I think policymakers should understand is if they need to help invest in science and scientific solutions, and also to convince the public and the media and all the stakeholders that only by investing in scientific solutions that we can bring about some of the problems that organic farming seeks to solve. And that is going to be my message to the policymakers. Do not just believe in facts. Just believe in viable, proven solutions that could help our people in the long run.
Sir, what exactly, as a scientist or scientific community, we can play in educating the public about the biotechnology? What all outreach we can, plan out to bring about this awareness,
Right.
not just considering the GMO, but also to general outreach for science, so that the general community also understand what exactly are development happening. So what exactly this in a simple language to a layman, so that they can understand things better. Because after COVID, everyone knows what is DNA RNA, but that outreach
Yeah.
has to be more than that.
Exactly. No, I agree. Scientific outreach doesn't necessarily mean educating or creating awareness of science behind the product. A lot of times we are not interested too much in details. For instance, there was one time I remember there was a scare that all the mobile phones that we're using are going to cause brain tumor, right? And so what we needed was an assurance from medical specialists that it is not so. We don't necessarily need to understand the intricacies of the physics behind cell phones or its effect on the brain. And I think that is what is needed, is an assurance from trusted individuals at the top, whether it's public policymakers or scientific figures, you see, who tell the public that this is a way forward, and also to create a rational thinking in and how we analyze problems. You see, a lot of times in India, we simply try to believe what we hear. There's so much WhatsApp messages as we get, and I'm really aghast at a lot of rubbish that comes along, and people simply believe. Even my friends who are seemingly very highly educated forward me some messages, or this can cure, baking soda can cure cancer and things of that nature, which if we trust, it's going to cost a lot more damage, right? Even the great Sadhguru, who has a lot of wisdom, recently when he had had to go through brain surgery, had to trust modern medicine, that he was, bringing so much canvassing and propaganda against. And so that is what we need in India, is an increased rational analysis of future problems. And there's nothing wrong in being proud about our past wisdom and progress, because India has an incredibly scientific powerhouse in historically. We had great awareness of astronomy. We had great awareness of, we were the first to do surgery and bring yoga and so much contributions to the world. And moving forward, while we could still be proud of our past, we must embrace the past but also see forward in the future, because we could not have sent that device to the moon with just our past knowledge alone. It needed science. It needed modern scientific understanding to send the Chandrayaan to the moon and to the Mars. And so India, to move forward in agriculture, needs the same mindset, that we need to move forward by embracing solutions and innovations that are based in science, that are based in reason, and we should not be swayed emotionally by fads, and fear of technologies should be not be based on emotion, but we need to analyze that more rationally. And I think that is my message to the policymakers and even to the Indian academic community, to be more open-minded and be more optimistic about these innovations.
So, because in I think the USA has been more acceptable to the GM crops, and there you must be having several GM crops that were developed and reused. So, have you ever witnessed that any problem or any issue due to that GMO? Because farmers are using those crops. So, any
Mhm.
issue regarding the use of GMO on regarding the effects on health and any other issue? Have you
Right.
ever received from?
No, not well. Agriculture is a very complex operation, and it will always have problems, and new problems will arise. But there is nothing that is specific to GMOs. You see, a lot of times crops fail, and new pests, strains, and disease strains would evolve to negate. And so that is, we have seen that in the same with with BT crops, for instance, been taken over by certain insect strains. But that is nothing, I know that has always happened with varieties of crop plants. And we have not had anything. And so the problems many of that people are worried about that are not specific to the type of plant breeding that you use to bring about a new variety. And so clearly with genetic engineering, we have not seen any problem, not just in the United States, but we are 200 million hectares of that being grown in about 28, 30 countries now grow GM crops. So I've been to most of these countries and I've talked to a lot of farmers and I've been to go to a lot of scientific meetings where we discuss the problems of biotechnology, and there are more than 3,000, 4,000 publications that looked and evaluated all of these crops, and there's been a few problems that have come about, and but they are not unique to biotechnology. There's nothing catastrophic that has happened, and there's not been on the other hand, with a lot of other technology, even including organic food, many people have died. You see, because of the bad samples, so E. coli contamination, microbial contamination. There's not been a single instance of any harm to any human being or any livestock by the consumption of GM crops. And there has not been any environmental too. The problems are more agriculture in nature. For instance, in the use of BT cotton, 95% of that, a new type of pest that evolved in India called pink bollworm that was not an earlier a problem. And again, that has been solved mostly due to better management systems. And so newer problems might come about by the use of biotechnology, but by also being very science minded, we can bring about solutions to them too. So it is not the end of the world. By using antibiotics, we are able to solve a lot of disease problems, but also give rise to antibiotic resistant strains, you see. And so problems will always arise with the use of any solutions. We just need to be mindful of that and see how we can solve that.
So, sir, you are also co-founder of Egg Bio. So, could you please elaborate on its mission and how it has been contributed to the promotion of understanding and uh, acceptance of agricultural biotechnology globally?
Yeah.
Is your vision
Certainly, yeah.
aligned?
Yeah, so Ag Bio World I started about 25 years ago as a foundation to help really bring awareness of agricultural biotechnology issues around the world, to help bring a greater understanding of this science, and to a lot of controversies that arose, to see how I can mobilize the scientific community to address that. And so, for instance, I had about 25 Nobel laureates to sign a petition 25 years ago to say that this is a safe technology that can bring a lot of benefit, and we should not be too preoccupied with all the risks that we are talking about, because many of those risk issues can be addressed and can be tested and make sure that there is not going to be any harm from the use of this technology. And so today I don't really run Ag Bio World as much as a foundation, because I'm more active on the social media, because I realized at that time there was no Facebook, there was no Twitter. And so I had to use a newsletter. I had to have what we call as a discussion groups on the internet to debate and talk about these things. But today, because there is social media, and I use the same Ag Bio World as my Twitter and Facebook handle, but to bring about a daily dose of scientific information, what about the new papers that have come about, and also new controversies that come out, and how we can address that.
You keep pace with the developments happening around. I see and follow your post on a routine basis. You have been routinely updating and posting some new discovery, new innovation, and similarly, as you were saying, that controversies and all. So it's a commendable effort from your side,
Thank you.
and with so much of busy schedule, you still have that reading and then sharing this information to others. It's very
Thank
great
you.
thing about you, sir. So, sir, your journey from India to pioneering the biotechnology research is very inspiring. Could you share some pivotal moments of your upbringing, how your upbringing has inspired you and to take up science and especially the plant biotechnology research?
Oh, thank you very much, Dr. Bal. Well, looking back, I think I was very fortunate in having a mother who was a science teacher. She was a high school teacher who had chemistry and biology. Her father was a high school headmaster from my mother's side, and my grandfather from my father's side was the deputy director of agriculture. So I spent my childhood, especially during the summers, going around with my grandfather with all the villages where he had after he retired, he started an agricultural business. So much of my joyous time of my childhood was really, although I grew up in a city like Bangalore, but I was really inspired by agriculture. And then I I joined, although most fashionable tendency even today in India is to go for medicine or engineering, I chose to go to agriculture because I just had a love of nature and plants. And I thought this is one area that is more close to my heart. And believe it or not, when I was an agriculture student in the very first year in the early 70s, Dr. Norman Borlaug came to my university and gave a lecture. And listening to his lecture and talking about all the amazing things that he has done, as a young agricultural student, decided to go into plant breeding because of the listening to Dr. Borla, and also somebody who had experienced and seen so much food scarcity around me, probably helped me to see if there is in some way I can be a part of the solution. So I don't think there was any conscious effort on my part, but I think it's a convergence of several things that shaped my childhood to go into this area. And I was always been a kind of science communicator during my undergraduate days. I used to write in the local newspapers. I was a cartoonist actually when I was in intermediate in pre-university, writing for newspapers. And so I kind of followed it up and started writing about agriculture in the newspapers, and then when I did my PhD, which is always PhD we work on very specific scientific area, but I produced a 5-minute movie on explaining to the public what my research is about. You can still find it on YouTube on popular league. My PhD was in 1985.
At that time, you have created that video.
Yeah, I created a movie. There was a TV unit in the university, and in early 80s, I was a science journalist for a newspapers in Bangalore. So I had that element of science outreach always a part of me. And then I carried it with me. And then suddenly when my area became very controversial, because I was one of the few scientists who was also into the public arena and talking about science, I was simply drawn into this controversy, and it changed my life in so many ways because, believe it or not, I've probably given more than 1,000 interviews and been on every major TV, newspapers, magazines over the past 20, 30 years. Delivered lectures in over nearly 100 countries in major forum, whether it's United Nations or World Bank. Even had an opportunity to visit Vatican a few times and even meet with the Pope. And so, while I was always a scientist, having this science journalism kind of took me around the world.
Your advice to the young generation of researchers and students? That would be the last question.
Absolutely. Yes. I believe that young people today are far more resourceful and far more smarter than my generation because they have so much access to information, and they are very conscious of the environment, and they are also very worried about the future because they see all these problems. My advice to young generation is to trust in science and to believe in science as a solution to some of the problems and use it in a meaningful manner, because not all scientific applications have been good for humanity. Everybody can recite many instances harm. For every technology, there is a negative part to that too. What I suggest to young people is to be a part of the solution, because there is so much wonderful opportunities today here, whether just in biotechnology or information technology, including artificial intelligence, and to draw from all the past wisdom that we have, especially in a great Indian society like ours with so much history. But be optimistic. Do not lose, do not be dissuaded by naysayers, because every generation today has lived better than the previous generation, and today's India's generation is much blessed, much fortunate compared to my generation or my parents' generation. And you and your children are going to live better, are going to live longer. You're going to have a much health, not only live longer, but you have a better quality of life. And it's all going to be made possible by new innovations in medicine, new innovations in agriculture. And what we need to do is to have a mindset to make that possible.
And thank you so much for taking out time for this conversation. We are blessed to have you on our show. Thank you so
Thank
much
you.
for this opportunity, sir.